welcome back to yet another video. This is your boy Hank Hackerson at Hank's Hacks Hackers. Wow, that was tough to pronounce for some reason. I hope you're having a good one. I hope you've been learning a lot. Today's video is continuing from the SOC Level 1, the Security Operations Center Level 1 pathway, where you get trained to become a security analyst. And we're going to be talking about network security and traffic analysis. We already did the first one. So today we're going to be talking about Snort, which is a very, very important tool, and it has 3 modules attached to it. So we're going to be doing the very first one, which I believe is more of an introductory module and kind of just trying to figure out some of the basics of how Snort works, etc., etc. So this is a free room in TryHackMe, which means you can deploy virtual machines without being subscribed, which is very, very awesome. So definitely go ahead and get yourself the membership. And if you wanted to advance and go into some of the more advanced rooms, you would require paid membership. And for that, you can use the link in the description below, and you would get a discount towards your membership. And then you can just go into a lot of the advanced rooms, use a lot of the advanced machines, so on and so forth. If you want to just do this on your own machines and just watch the videos and follow along that way, you're more than welcome to do that. And the only thing you would have to do in that regard is just like, subscribe, and turn on the notification bell so that you get notified the next time a video comes out, and then we'll just kind of continue along the pathway together. So that being said, without further ado, let's jump into the introduction of the room. Okay, so for the introduction, basically it's saying that you need to be familiar with Linux commands, basic Linux functionalities on the command line, like general system navigation and all that stuff. And if you don't know that, I'll try to explain as we go along, but it's pretty simple to learn, and you can find a bunch of like Linux command line worksheets that will kind of help you do all those things. And then you also need some basic network fundamentals. So you need to know what ports or the standard ports are, the protocols, and traffic data, stuff like that. So what you're going to learn to do is start working with Snort to analyze live and capture traffic. And the live part is what I'm really interested in because I think it's very important to be able to analyze live traffic and make moves accordingly. Before joining the room, you got to complete the network fundamentals module, which I have done. So if you haven't done it, I recommend you do it. And I think this is also a free room on TryHackMe. Well, they have 2 free modules, but then they have a couple of VIP modules, which basically require that you get a subscription. So if you don't, again, if you can't afford the $7, because it's $12 to start, but then if you use the link in the description, it becomes $7. So if you can't afford the $7, you're more than welcome to just go ahead and look up all these things online and kind of read through them that way. I just like using TryHackMe because they offer labs and you can try a lot of these things in a controlled environment. So no biggie in either case, and we're still going to go forward with this, and I'm going to do my very best to try to train and teach you and all that. And yeah, no judgments, no hard feelings, none of that stuff. So don't worry about it in any case. No matter what, you're going to end up getting the information. So just know that I love you and I'm here for you. So you need the network fundamentals. So if you haven't done stuff like that, you got to go and learn those things because it might be a little bit tougher to get through this room. Then if you need assistance, Linux command line, then there's the Linux fundamentals, which we've already done. And Snort is an open source rule-based network intrusion detection and prevention system. Okay, nice. So it's like all in one kind of a thing, but it's for the network specifically. And it was developed and still maintained by Martin Roche, I think that's how you pronounce that, and some open source contributors, and of course Cisco Talos, and we did a video on Cisco Talos as well on CTI, so that's really, really cool too, cyber threat intelligence. The official description is Snort is the foremost open source intrusion prevention system in the world. It uses a series of rules that help define malicious network activity and uses those rules to find packets that match against them and generate alerts for the users. So it is the foremost open source intrusion prevention system in the world. So I'm excited about this. I've never used it before, so I'm very, very excited to go through this room with you guys. So that was our little intro. Okay, so we need some interactive material and the virtual machine. So I'm going to start that virtual machine. It's going to give us a split view, so I don't think we need to actually start an attack box for this room. And so the interactive material, once we start it, it says that, you got to do the show split view. Once you've started it, everything you need is located under the task exercises folder, which is going to be on the desktop from what it looks like. And so there are two subfolders that are available. There's the configuration samples, and then there's exercise files. So sample configuration rule files, they show you what the configuration looks like. Install Snort instance doesn't use them, so feel free to practice and modify them. The original base files are located under etc Snort. And then you have the exercise files that are separate folders for each task. Each folder contains a PCAP file, which is basically a capture file, and log and rule files ready to play with. So very excited. Then we have a traffic generator. So it's offline, but there's a script, which is trafficgenerator.sh for you to generate traffic to your Snort interface. You will use the script to trigger traffic to the Snort. Once you run the script, it'll ask you to choose the exercise type and then automatically open another terminal to show you the output of the selected action. Okay, cool. Note that each traffic is designed for a specific exercise. Make sure you start the Snort instance and wait until the end of the script execution. Don't stop the traffic flood unless you choose the wrong exercise. Got it? Run the sh by executing in sudo and then ./sh file. That's basically how you run any sh script, is ./ and then you have to be inside the directory that holds the script, right? So you could do ./root/traffic if it's inside the root folder, but you're not inside the root folder. You know what I mean? So general desktop overview looks like this. The exercise file manager, obviously, this is going to be our command line, and then you have the traffic generator. Select a file pattern to feed the pig. Once you choose an action, the menu disappears and opens a terminal instance to show you the output of the action. Look at that. This is the traffic being generated, a bunch of stuff, source IPs, destination IPs, a bunch of echo. It seems like it's all echo, basically. Echo, reply and request, reply and request. And yeah, that's pretty much what we got. So navigate to the attack exercises folder and run the command .easy.sh to write the output. Okay, so let's go to the show split view here, and we need to go to the task exercises folder. The machine is almost up and running, 99%, 100%. There's our machine, and we need to go to task exercises, which is right on the desktop, and we're gonna run what exactly? Oh, I think I need to be inside the terminal doing that. So from the terminal, so ls, let's kind of go in a little bit so you can see what's going on. So ls lists what is inside your current directory, and then pwd works inside what your actual, what your working directory is. So we're in the home Ubuntu directory, and the task exercises seem to be on desktop. So we're going to cd for change directory, and desktop, and then ls one more time. There's the task exercises, and if you don't want to type the whole thing out, you could just do tab. So I do task tab, it fills up the rest of the stuff, and now we're inside here, and so there it is. So it says go to the, or maybe I need to be in exercise files, maybe that's what it is. Is there easy in here? There is no easy in here. So it just says task exercises, right? Navigate to the task exercises folder and run the command. Maybe if I did ls.la, is there something else? Yeah, there it is. That's what we're looking for, is easy.sh. What the hell? What happened? That was weird. Okay, whatever. So if you do ls, a lot of times it doesn't show you everything inside the folder. So when you do ls-la, it'll show you everything that's also hidden and all the other commands. So when you do these two, it goes back one directory, so it'll go from task exercises back to the desktop. So that's kind of one option that's available. So now what we want to do is we want to do ./.easy.sh, and what is the output? says too easy. That's all we need for our first command here. So too easy. There you go. Easy does it. And all right, so that was our, interactive material and VM task, and that's done. So moving on to the next one. Okay, so introduction to IDS IPS, just so we can kind of see what's going on. So there is IDS, which is for detection, and then IPS, which is for prevention. And just to kind of give you like a general overview of this without really going into the nitty-gritty here. Intrusion detection is for monitoring and detecting possible activity or abnormal incidents, etc. And it's responsible for generating alerts for those events. So you have the network intrusion detection system, and then you have a host-based intrusion detection system, which means it's on the computer, on the machine itself. The network intrusion detection is detecting everything on the traffic, right? So monitoring everything on the network traffic from various areas. The aim is to investigate the traffic to the entire subnet, and if a signature is defined, an alert is created. This one monitors the traffic from a single endpoint, so one machine. The aim is to investigate on a particular device, and if a signature is identified, an alert is created. That's intrusion detection. Intrusion prevention does the same thing almost, but what it does is to protect the traffic from on the entire subnet. If something is identified, the connection is terminated. So it takes a remediation action, is what it's called. It actually does something other than send a notification to whoever the analyst is and say, hey, go check this out, right? Intrusion prevention actually stops things from happening. And there's other modifications and configurations that you can do that it does more than just terminate the connection, right? It's very useful. Then you have behavior-based IPS or network behavior analysis, etc. Behavior-based systems monitor the traffic from various areas of the network. The aim is to protect the traffic on the entire subnet. If a signature is identified, the connection is terminated. So similar responses at the end, but they just do different things, right? So you have the network intrusion, monitors the traffic from various areas of the network. The aim is to protect the traffic on the entire subnet. This is behavior-based. So if it's not flagged, if any specific activity isn't flagged, it'll kind of look at the behavior and be like, this kind of lines up with the series of activities that can be done to do an attack. And so if it detects that certain behavior is being done, it'll terminate the connection. So it's useful in a lot of different ways, honestly. Network behavior analysis works similar to NIPS. Difference between NIPS and behavior-based is behavior-based systems require a training period, so also known as baselining, to learn the normal traffic and then differentiate between malicious and normal traffic. This model provides more efficient results against new threats. The system is trained to know the normal to detect abnormal. The training period is crucial to avoid any false positives in case of security breach. During the training period, the results will be highly problematic. Another critical point is to ensure that the system is well trained to recognize benign activity, so it doesn't give you false positives, right? Then you have wireless intrusion prevention. Monitors traffic flow from wireless network. The aim is to protect the wireless traffic and stop possible attacks launched from there. And if something's identified, it's terminated. Then you have host-based, which is, it does a single endpoint to a single machine. It does it on a particular device, and if a signature is identified, connection is terminated. So you can kind of just tell from the title, the name of them, what they actually do. HIPS working mechanism is similar to HIDS. The difference between them is that when while HIDS creates alerts, HIPS stops by terminating the connection. You have detection and prevention techniques, right? So they're signature-based. It relies on rules that identify the specific patterns of known malicious behavior. This helps detect known threats. Behavior-based identifies new threats with new patterns that pass through signatures. The model compares the known and normal with unknown abnormal. This model helps detect previously unknown or new threats, also known as zero-day. And then you have policy-based, right? So that's also pretty simple to understand. Compares detected activities with system configuration and security policies. This model helps detect policy violations. So don't go to a certain website that's a part of the policy. somebody goes to the website, there's a notification that comes up, or it just kills the connection, right? Basic. So summary, IDS can identify threats, but requires user assistance, so the analyst has to do the work. IPS identifies and blocks the threats with less assistance at the detection time, so it's like live blocking kind of a thing. So the rest of the official description of Snort says it can be deployed inline to stop these packets as well. Snort has three primary uses: a packet sniffer like TCP dump or Wireshark, a packet logger, which is useful for network traffic debugging, or it can be used as a full-blown network intrusion prevention system. And it can be downloaded and configured for personal and business use. It's open source, rule-based network intrusion detection and prevention. It was developed and still maintained by yada yada. We talked about this already. And capabilities are plenty, right? Live traffic analysis, attack and probe detection, packet logging, protocol analysis, real-time alerting, modules and plugins, pre-processors, cross-platform support between two different major platforms. And there's three use models: Sniffer Mode, Packet Logger, and NIDS and IPS. So we see what is happening here. So which Snort mode can help you stop the threats on a local machine? That would be host-based IPS. Then you have which Snort mode can help you detect threats on a local network? That would be network IDS. So detect is kind of the keyword here. And then this one stops the threat, so it's protecting, right? Which Snort mode which Snort can help you detect the threats on a local machine? So that would be H, so host-based IDS. And then which can help you stop threats on a local network? That would be network IPS. NIPS, like nipples. Anyway, stupid. Which Snort mode works similar to an IPS mode? Okay, so it did a basic little Google, and it says network behavior analysis system. So I'm gonna say it's either no, it's not BAS, or maybe it is BAS. We'll see. It's either BAS or network behavior analysis. Okay, there you go. Okay, got it. And according to the official description of the Snort, what kind of NIPS is it? I guess this could be an answer. So let's see. Full-blown. It's kind of a weird type of an answer, but okay, that's the answer. NBA, short for, what was it again? I totally forgot already what that stands for. Training period is also known as baselining. Baseline? Yeah, baselining. There you go. The NBA training period is also known as baselining. And let's try to find that one more time just so I can... There we go. So the network behavior analysis system, that's what it is, behavior analysis system, network behavior analysis. The training period is also known as baselining. That's what it is. Okay, good stuff. We got the answers for intrusion or introduction to IDS IPS. Now moving on to the first interaction with Snort. So let's verify that it's installed. So we're going to go to our terminal real quick. Clear, we'll clear the terminal, and you do Snort V for, I'm guessing, for version, and it'll tell you, look at this little piggy. There's a little piggy right here. That's cute as hell. So it'll tell you the version 2.9, whatever. Ours is the same, so we actually have the version. Before getting your hands dirty, we should ensure our configuration file is valid. Here, -T is used for testing the configuration, and -C is identifying the configuration file. Note that it's possible to use an additional configuration file by pointing it with C. So I guess you can do multiples. So this is in their desktop, or the basic thing right here. So I'm going to come out of where I am, and within our desktop or home folder, we're going to do sudo snort -c etc snort snort.conf for configuration file, and we're going to do -T for testing. And press enter, and there it goes. It runs. And now, so Snort successfully validated the configuration. It is now exiting. So it validated, it did a bunch of things, which I am not going to sit here and try to analyze all of this stuff right now. But we got a success result. I mean, look at this. There's literally almost 500 line items. So we got a successful validation on the configuration, which means that we are good to go. So once we use a configuration file, Snort got much more power. The configuration file is an all-in-one management file of the Snort, rules, plugins, detection mechanisms, default actions, output settings are all identified. It is possible to have multiple configuration files for different purposes, but one can run at a time. That's kind of important to know. Note that every time you start the Snort, it will automatically show the default banner, the initial information about your setup, and you can prevent this by using the Q parameter. So -V, which is what we already did, will give us the version. You can also do -- version, provides the information about the instance, -C, the configuration file, -T, self-test parameter, you can test the setup with this parameter, and -Q is for quiet mode, that prevents Snort from displaying the default banner and the initial information about the setup, which I mean is not that big of a deal because it wasn't that big of an output. But okay, so that was an easy one, I guess. So let's explore the Snort modes. So run the Snort instance and check the build number. So we're gonna do it one more time, and I'm just gonna do up to go to my last command and one more to get my Snort version command, or I guess two more. And so there you go. So what as it says, what is the build number? The build number is 149. So that's going to be my build number. Test the current instance with yada 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 and check how many rules are loaded with the current build. And that was, I think, how many rules? So let's see if we can find how many rules are loaded. Okay, so we got rule port counts, and then we have the total rules right here. There we go. So 4151 rules read, and so we're going to try that 4151 as our total number. There you go. And so test the current instance with snortv2.conf and check how many rules are loaded with that build. So we have this thing one more time, and so the command that we're going to run this time is going to be, everything is the same except this part where we change it to snortv2conf. So it would be sudo, come on, sudo snort-c etc snort, and then snortv2.conf, and you're going to do t, and let's see. Okay, so we got that, and now the question is how many rules are loaded with that build. So let's check that out. It says 1. Is that right? Okay, maybe 1. Okay, so 1 it is. All right. So okay, so we got our basic answers here. So first interaction with Snort, not bad, not intimidating at all. I like it so far. All right, so moving on from this to Operation Mode 1, Sniffer Mode. So Sniffer Mode is like TCP dump, where it sniffs the activity that's currently happening and it starts ingesting all that stuff. These are the parameters. So V for verbose, display TCP IP output in the console. D for display the packet data and the payload. E to display the link layer. So all these things that we've talked about. X, and this is a capital X, displays the full packet details in hexadecimal. Oh, that's hexadecimal to me is very intimidating. Like, I have no idea what the patterns are, how to recognize anything, and just looking at hexadecimal code or hexadecimal details freaks me out. And then you have I, which is the parameter to define a specific network interface to listen, sniff. Once you have multiple interfaces, you can choose a specific interface to sniff. So let's start using each parameter, and to do this, the traffic generator script in the task exercise folder is what we're going to end up using. So start the Snort instance in verbose mode and use the interface etho, which is sudo snort vi etho. And then in case you have only one interface, Snort uses it by default. The above example demonstrates to sniff on the interface named etho, or eth0, excuse me. Once you simulate the parameter v, you will notice it automatically use that interface and prompt it. And so sudo snort v, so start it with verbose mode. Now run traffic generator and start the traffic. Once the traffic is generated, Snort will start showing the packets in verbose mode as follows. And as you can see, the given output verbosity mode provides TCP dump output information or similar. So once we interrupt the sniffing with Control-C to cancel it out, it stops and summarizes the sniffed packets. Sniffing with D, which is packet data mode, and this, I'm guessing, it reads a specific packet data. So now run the traffic generator as sudo and start the traffic. Never mind. Once the traffic is generated, Snort will start showing the packets in verbose mode as follows. So this one looks like this, and then this one looks kind of pretty similar. As you can see in the given output, packet data mode covers the verbose mode and provides more data. And DE, so Snort in dump with D and link layer header grabbing E, like that. Now run it as such and start the traffic. Once the traffic is generated, Snort will start showing packets as such, which at first glance it all looks very, very similar to me. So we'll see what that looks like later. And then you have the X command, which is packet dump mode, and start it and run the traffic. We'll start showing in, okay, this definitely, because this is hexadecimal. This is, yeah. You see, this shit looks way more intimidating than this. This doesn't look that intimidating, you know? And so, okay, we got google.com here and google.com over there. Same thing with this. You see that this one doesn't show that part. Okay, fine. There you go. I guess we could see that part. V mode in verbose, that was it. And then you have the D parameter and actually starts showing some details, and then more details, and then X gives you hexadecimal. Yikes. And then, so these are the different parameters that you can do combined or separated as follows. So you could do V or VD, then you DE, and you could separate them by dashes as such. So you could probably do very similar to what Netcat does, and you just do one dash and then put all the parameters that you want. Make sure you understand and practice each parameter and discover your favorite combination. Okay, so let's run it. Let's run some of these things and see what the hell's up here. All right, the first thing that we want to do is start the instance in verbose mode and use the interface etho. In case you've only one interface, that will happen. Once you simulate the parameter v, you will notice it automatically running on such. So we're going to do sudo snort -v -i and then etho. Let's see what that does. Okay, so it's capturing, very similar to TCP dump. So it's just kind of like a live capture that comes in since we have an interface. And I'm just going to stop it because it's going to have a lot. And then now it gives us the final results of everything. So Snort exited and it captured, you know, the ether packets, IPv4, TCP packets, and what else we got? We got IP4 instances or disconnections, or I don't know what that stands for, and things that were discarded. So that is probably disconnections, and then bad checksums, 365, and so total of 1600 packets. And so this is basically what it looks like. It is very similar to TCP dump. It kind of just shows you the full live capture as it's happening. And as you can see, I mean, a lot of stuff was captured within the few seconds that we ran our interface detection. So this was a live detection kind of a thing that happened just based on the interface that we were on, which is ETH0. And just so you kind of understand what that means, so if we do ifconfig, it'll give us all of the interfaces that we got, right? So these are the interfaces that are available on our machine. You have ETH0, This is the IP address of it. You have ETH1, and that's the IP address. And then you have local, which is always going to be this IP address for the local machine. And so if we look at 10.10.8.214, it is ETH1, right? So that was the IP that was dedicated to, or ETH0, sorry, ETH0 was that's the IP that's dedicated to that actual machine, which means it's basically this Linux machine that we're on right here. That's ETH0, right? So that was the first version of the command. What happens when I do that? I don't understand why everything disappears. And it did it again. Okay, so the second version of the command is just going to be running it in verbose mode and then starting the ICMP traffic thing in a different window, in a different command line. So snort v. So we're going to start it, and it's still capturing, huh? So let me stop that real quick. I'm going to start another terminal and just kind of guide. And so this is what it said: run the traffic generator. So first start the instance in verbose, then run the traffic generator. Once the traffic is generated, Snort will start showing packets in verbosity mode as follows. All right, so first I'm going to go to desktop, and I'm going to go to task exercises, and there's the traffic generator, and so traffic generator.sh. I'm not going to press enter. First, I'm just going to have that loaded. Then I'm going to go here. I'm going to start Snort in verbose. Go here, start traffic generator, and we're going to do whatever, ICMP traffic, I guess. Start that. And there was an error creating child process for this terminal. Failed to execute. No such file or directory. Okay. Is that running in the background? I feel like it should be running, right? So total of 5,000 and running in packet dump mode. Am I missing something? So start the Snort instance in verbose mode. Then run the traffic generator script as sudo and start ICMP HTTP. So I didn't run it with sudo. Maybe that's what's wrong. So if I do sudo traffic like so, then let's do this one more time. We're going to start that, go here, start that, and then ICMP HTTP. Can I do multiple? Can I choose multiple? Okay, I did ICMP last time. Let's do HTTP. Open this up. Oh, there you go. Look at that. Okay. Okay. So traffic is being generated now. And so it finished generating the traffic. And this is our Snort instance. We're going to close that. 4682. And this is the traffic that's being generated. So this is the output, what's going to look like. So compared to the actual sample output that it gave us, it is true. That's exactly what it looks like. So, and that was basically sudo snort verbose. That's basically what this was. And I want to learn how to search through this. Maybe we're going to figure out how to search through this later on. Oh, search, find. And what can I do here? What can I search for that would be useful? I don't know. I don't even know what to search for at this point to try to figure out what would be useful. But okay, we'll kind of get there when we get there. So now we're going to do the same thing. So we're going to load it up. There it goes. And then we're going to go here and we're going to load this up. And now instead of V, we're going to do D. And so sudo snort. And it's going to start running. Look at that. Data dump mode. And then now we're going to run this mofo and do HTTP traffic. Start that. There's a bunch of traffic. I kind of want to... there's all the traffic, and then the traffic died. And then we're going to stop this thing. 3386. And let's see what the traffic looks like. There you go, data dump mode. Is that what this is? This is data dump mode, right? Data dumping packet data mode. Okay, I guess. uh, the data looks different. That's how I know that this actually worked the way that it's supposed to. And I want to get to a point where we can search for things and where we can try to find specific IP addresses or something and try to kind of just get more information that way. So that's whatever with that. And so parameter DE, which is going to be dump, as well as link layer header grabbing mode. So it should be getting headers for us. So we should actually be seeing extra information. I mean, we do kind of already see something like that here already. So the header information, I guess, is this piece right here. Although that's also there. So what would I get here? Nope. The difference in these things is not that much to me. I don't understand exactly what the difference between these packets are right now. But okay, whatever. So let's do it again. So we're gonna go back here. We're going to load up our command for traffic generator, and we're gonna go here. And my stuff disappeared again. And now we're gonna do snort, or excuse me, sudo snort de. Start that. Go here. Start that. HTTP. Okay. There's the traffic. And let's see what happens after this thing loads. There's that. Stop this. Okay, 2725. And what do we got in this mode? The header information. It does look like there's more information actually, so I will say that. So there's this, and it looks like we have the MAC addresses maybe, and the IPv4 versus IPv4 destination, and source IPs, all of that. Okay. All right. So now hexadecimal. Okay, here we go. Hexadecimal. Full packet dump. Sudo snort x. And go back here. Load that mofo. And maybe if I press this first, and then do this. No. This, and then boom. Maybe just minimize that and see what it looks like in real time. There's that. And the traffic probably ends quickly, right? And then so we could stop. There we go. Definitely more data. I'll give you that. There's just more information per packet. And if we knew what we were supposed to be searching for, we could probably get some really good information. But so we just practiced the commands, basically. That's all we did. We just practiced the commands. And there's the Snort X mode. And so let's go back to the top just to get a review of what these things are. So you have verbose, packet data, which is the payload, link layer, which is the headers, display of full packets in hexadecimal, and then this specifies which network interface you want to listen on and you want to sniff on. So that was the general approach to our first ever operation mode, Sniffer Mode. And so we finished that. And so now we are going to move on to Operation 2 Packet Logger Mode. So we had the Sniffer Mode, and now we're going to look at Packet Logger Mode. And so the Logger Mode has L for logger, probably, log and alert output directory. The default output folder is the var log snort folder. The default action is to dump as a TCP dump format in this thing. So maybe instead of showing it onto the screen, it'll actually dump it into a log file, which is way better in my opinion. And then you have KASCII, which logs it in that format. And then R, which is in reading option, so read the dumped logs in Snort. N is the number of packets that will process and read, so we can probably max out how many packets that we wanted to run. And so instead of going to thousands and thousands, we could probably say, hey, take the next 500 packets or something like that. Log file ownership. It is, before generating logs and investigating, we must remember Linux file ownership and permissions. No need to deep dive into these things. The fundamental is whoever creates a file becomes the owner of the file. So in this situation, it's us. And then if we run it as root, then we would get root permissions to our files. So when you run it as sudo, the root account will own the generated log files. Therefore, you will need root rights to investigate the log files. There are two different approaches to investigate generated log files. There's elevation of privileges, and this is privilege escalation essentially. You can elevate your privileges to examine the files. You can use the sudo command to execute your command as a super user, which is sudo read whatever or sudo open. You can also elevate session privileges with the switch to the super user account to examine the files with sudo su, so switch user. Changing the ownership of the file directory. So you can also change the ownership of the file or the folder to read it as the user sudo change ownership username, and in the file sudo change ownership username directory. The R parameter helps recursively process everything inside that directory and other directories inside that directory. So logging with L looks like this. So sudo snort dev L, there we go. And so then you start the traffic. Once the traffic is generated, Snort will start showing the packets and log them. You can configure the default output in the config file. However, you can also use the L parameter to set a target directory. Under identifying the default log directory is useful for continuous monitoring, and the L parameter is much more useful for testing purposes. So the L dot, so the dot part of the command creates logs in the current directory. That's very useful. You will need to use this option to have the log for each exercise in the folder. So sudo snort dev, and what was dev again? Does it say it here? It doesn't say it here. Does it say it here? It does not say it there. So dev L and then dot, so that it's in the current directory, and it'll create it in logging mode. And then you'll look at the generated log file, which will look like that. Now the file names is going to be different, obviously, in our case. As you can see, it's a single all-in log file. It's a binary TCP dump format. This is what it looks like in the folder. And then when you log as this type of a format, and then you just do L dot, it will do the log in that format, and it'll put it inside the current folder. And then you look at the log file. So this was our first one, and then this is going to look like this in this particular situation. So I guess it's going to have a folder, or a directory, excuse me, that is dedicated to this IP, and then there's going to be one dedicated to that IP. The logs created with that parameter are entirely different. There are two folders with the IP address names, and so if we go inside this one, you can see that this is what's in here. So these are the different files that are in there, and these are all UDP traffic, ICMP echo traffic. In a nutshell, the ASI mode provides multiple lines in human readable format, so it's possible to read the logs easily by using a text editor. By contrast with AC, we'll call it that, binary format is not human readable and requires analysis using Snort or an application like TCP dump. Let's compare AC with the binary format by opening both of them in text editor. The difference between the binary log file and the AC log file is shown below. So left side is binary, right side is AC. And this, I would say, is definitely more legible than this. This is just a bunch of ones and zeros, kinda. And then this is a little bit more legible. So it actually shows you the source address and the destination address and time to live and whatever might be inside the hexadecimal packets right here. So definitely better and easier to read. Reading generated logs with the parameter R, so sudo snort R, and then the log itself that you're trying to read, and it's going to read it. Note that Snort can read and handle the binary like output TCP dump and Wireshark, and however, if you create logs with the AC parameter, Snort will not read them. As you can see in the output above, Snort read and displayed the log file just like in Sniffer mode. Opening the file with TCP dump will look, this is, I think, easier in my opinion, because it's like one line per transaction. but that's neither here nor there. Opening in Wireshark, very, very cool. I always love doing that because it has GUI, and there's just way more information that you can get from each captured packet, and you can navigate the packets in more detail. The R parameter also allows users to filter the binary log files. You can filter the process log to see specific packets with Berkeley packet filters. So sudo snort read, log name log, and then X, and then ICMP TCP, UDP in port 353, okay? The output will be the same as above, but only packets with the chosen protocol will be shown. Additionally, you can specify the number of processes with the parameter n, so the number of lines that it will bring for you, and it will process only the first 10 packets for you. These are all the resources to understand how the Berkeley packet filters work. And then now let's look at this and go to task 6 to answer the following questions. So let's see what we can do here. I'm gonna do my very best to try to make this, I don't know, run smoothly, but this is my first time doing this, so we'll see what happens. So we are in task exercises. We need to go to exercise files, and in here we need to go to task 6. Task 6, there we go. And in there, ls needs to be lowercase. That's the log file for the traffic that was generated. So it says investigate the traffic with the default configuration file with ASSAC whatever mode. Execute the traffic script and choose task 6. Wait until the traffic ends, then stop the snort instance. Now analyze the traffic output summary, etc. So you should have the logs in the current directory. Navigate to folder so-and-so. What is the source port connected to port 53? Okay, so what we need to do is run the traffic generator file one more time. And I think I could just go here and double click it probably. I could just do this and double click on that. So what we're gonna do is we're going to run this in a log format so that it creates the log for us, right? That's what I was supposed to do. Sudo snort dev k ascii l, and then in the current directory. So that's what they want us to do, right? So go here, execute the traffic generator and choose the task 6 exercise. Wait until traffic ends, then stop the snort instance. Now analyze the output summary and answer the question. Okay. Okay. So, okay. Sudo snort dev k ascii l, and in the current directory. And this thing is running it as a sudo command. So I think I should actually open it in a terminal. So just to make sure that we don't mess anything up really. So let's see. What was it? It's going to be cd desktop ls cd task exercises ls, and there is the traffic generator sudo traffic generator. Okay, let's hope this works the way that it's supposed to. So press enter here, it's capturing packets. Press enter here, HTTP I think, or ICMP, whatever. There you go. It's gonna start running, and traffic is gonna go, and it's gonna go, and da 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 da, and there you go, and end this. So there should be a log file in here now. Oh, there you go. Holy cow, there's several. Okay, so there's a bunch of stuff in here, and so we want to go to the one with 237. So CD 145 254 160 237. What did I do? CD 145 254 160 237. Permission denied. Sudo CD 145 254 160 237. There is no sudo command. Okay, so what was I supposed to do? Change the permissions? Something like that, right? Let's go back up and look at that particular section with changing permissions. So what if I do sudo su root? Okay, now I'm root. Okay, so now maybe I can do cd 145.254.160.237. Okay, cool, yay. There we go, ls, and these are the packets, right? Where is it? Is there anything in there? And what is it? 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 So we did that. Now you should have the logs in the directory. Navigate to that. What is the source port connected to port 53? So I'm gonna say it's 3009. It's connected to 53. 3009. That is the answer. All right. Okay, so now use the log that ends in 8004. So let's go back one, ls, and it's right there. So sudo, right? Or do I even need to do that? I don't think I need to do that. So snort read snort log n and 10. So give me the first 10. And so what is the IP ID of the 10th packet? So let's go up here. Packet totals, where's the 10th packet? This is the 10th packet. So what is the IP ID here? There's the IP ID. Copy that. Paste that. That should be it. That is it. So now read this thing with snort. What is the referrer of the 4th packet? So this is, I'm guessing packet 10, packet 9, 8, 7, 6, 5. Oi, I went too fast. Okay, so commencing packet process. So this is the first one, second one, third one, and the 4th one. So what is the information? What are we doing? What is the referrer of the 4th packet? Okay, so I think I need to read this in a different format because I need to be able to find a link, like an IP address. Or maybe I just need to, so the referrer is, right? Wait, let's see what the hint says. X helps you display the full packet details. Okay, got it. So then we are going to run the command one more time and we're going to use X. Okay, I guess we can't do multiple options. I had to actually just use X. And so now I need to go to the 4th packet, which is, I mean, bro, this is a lot of packets. And this is the referrer information. I can't copy all of that, so I actually have to type that in. But it's basically the last piece of information on the packet. And so it is http://www.ethereal.com/development.thm. Oh, my bad. HTML. There you go. Development.html. Okay, so read it with snort. What is the ACK number of the 8th packet? So this is pack number 4, 5, 6, 7, and 8. The ACK number is this thing. That's the acknowledgement number. Copy that. Go here. Be right. That is right. Great. So read it with snort. What is the number of the TCP port 80 packets? So if we go all the way down, it should be at the very, very bottom, I believe. So TCP port 80, 41, right here, like so. Okay, so this was a bit of a learning curve for me, but I mean, it wasn't that bad at all. And the hardest part was learning that you can't combine the number packet. So if you want to, or the number flag or parameter, you can't combine that with X. So you can read the whole thing and do -X, but you can't do -N10. So this is the command, right? So these are the different ways that you can read this thing. And I could have even, I could do it like this. I think I should do this. Let's see if we can do that. That would be an interesting way to do this. Because I think that might be the command that we're supposed to use to try to find snort r snort.log. And then I want you to do TCP and port 80. Come on, bro. What happens here? So a total of 41. It gave me right away. Gave me the answer, and these are only the packets that are TCP and 80. So that's the good command that we're supposed to use for finding things like that. And what is the ACK number? So the ACK number of the 8th packet. Is there a specific command to get that? TCP, ICMP, and that. So I guess I could have just done, I could have ran it with sudo r snort, sudo snort r, and then the snort log, and then we're going to do N8. Let's do it like that. And it would only read 8 packets for us, and then from those 8 packets, the very last packet, which is showing up right here, it would give me the acknowledgement number easily right there. So yeah, so I could have just, instead of kind of scrolling through that list, I could have done it this way and been a little bit better at my searching and the reading of the file. So this particular one, I did exactly as they commanded, which is, use the X command to be able to read the full thing, and that's how we got the referral link. This one was the ID of the 10th packet, which is basically exactly what we ran, and we went to the 10th packet and navigate to folder yada yada. What is the source port of the thing that connected to port 53? And we saw that already, and the rest of it was pretty good, so it's not bad. So this thing is the big thing. I would say that's another learning curve moment right there, that I learned that I can read the log and search for versions of scans or packets exactly. So instead of UDP, we did TCP and port 80, and immediately it gave me exactly 41 as my total count at the bottom right there. And so that's how we knew. But what I did in the first instance to actually get that answer was I scrolled up and I went to the portion that said TCP, and I read the line item for TCP, which is in this instance is 8, but in the previous instance it was 41. It actually showed us the 41. There you go. That's what it is. So I went over here and I scrolled up, and out of all of the packets that were available, I found the line item for TCP, and I saw that it was 41. But when you run the command searching for TCP, the total number of packets are also 41 because it only brought that number of packets. So that's actually very useful. I'm very, very glad that I kind of did that extra command at the end there just to try to figure out how to do that. And so now we know. Now we know. And this was the completion of Operation Mode 2, the Packet Logger mode. So now we're going to be moving on to Operation Mode 3, which is IPS mode of Snort. Look at this pig right here, bro. What is that? That is a monstrosity. What the friggin' hell? What is that? That's so weird. Because these are the ears for sure, I'm guessing. What the fuck is this shit right here? Is it like its hind legs that are in the air? Or no, it's standing on its hind legs and these are the front legs? That is freaky. Okay, moving on. That's a weird ass image. So Snort and IPS. Note that these modes depend on the rules and configuration. Task 10 summarizes the essential paths, files, and variables. Also, Task 3 covers the configuration testing here. We need to understand the operating logic first, and then we're going to go into the rules in task 9. So these are the operating logic. So these are the parameters. -C, defining the configuration file, T for testing, N for disabling logging, D for background mode, and then A for alert modes. And then you have full fast console CMG, which is the basic header details with payload and hex and text format, and none, so disable alerting. So these are our basic IDS IPS modes. And then so let's start using each parameter and see the difference between them. Snort needs active traffic on your interface, so we need to generate traffic to see Snort in action. To do this, use the traffic generator script and then sniff the packet. Once you start running ID IPS mode, you need rules. So as we mentioned, we'll be using a predefined ICMP rule as an example. The defined rule will only generate alerts in any direction of the packet activity. So you have alert ICMP any, and that goes to any, and then the message is ICMP packet found SID 100,001 rev1. So this rule is located in the rules folder in the rules file. Remember, in this module we will focus only on the operating modes. These rules are covered in task 9 and 10, or the rules, excuse me. Snort will create an alert if the traffic flow triggers an alert. One last note: once you start running IPS IDS, the sniffing and logging mode will be semi-passive. However, you can activate the functions using the parameters discussed in the previous task. And these are all the parameters that we had in the previous task. If you don't remember the purpose of these commands, please revisit task 4. I probably will have to do that. And so running it with C and T, sudo snort C, which is the configuration file, and then T to test it. This command will check your configuration and prompt if there's any misconfiguration in your setting. You should be familiar with this in task 3. If you don't remember the output, please revisit task 4. And running it with the parameter N, which would be to disable logging by running it as such. Now run the traffic generator script as sudo and start ICMP traffic. This command will disable logging mode. The rest of the other functions will still be available if activated. The output will provide information requested with the parameter. So if you activate verbosity or full packet dump, you still will have the output, but there will be no logs in the log folder. And then running it with D, to run it in background mode. Now run the script, and then once the traffic generated, Snort will start processing and accomplish in the with the additional parameters. The command line output will provide the information requested. So if you activate verbosity and all of that, you'll still have the logs in the logs folder, but there will be no output in the console. Okay. Once you start the background mode and you want to check the corresponding process, you can easily use PS command as shown, which is PS EF grep snort. So in the processes, we're going to look for snort. And this is one of those things that was covered in the Linux rooms, just so you can kind of understand what that means. If you want to stop the daemon, you can easily use kill. So kill process 9. And so it should say, I mean, that's the ID of it. Kill 928. Oh, excuse me. This is the ID. My bad. So this is the ID. So kill 2898, and it's gonna stop it. And so daemon is used mainly to automate snort. This parameter is mainly used in scripts that start the snort in the background. It's not recommended to use this mode unless you have a working knowledge of snort and stable configuration. Using it with the parameter A is the alert modes that we have available. And so in this section, only the console and CMG parameters provide alert information in the console. It's impossible to identify the difference between the rest of the alert modes via the terminal. Differences can be identified by looking at generated logs. At the end of this section, we will compare the full, fast, and none modes. Remember that these parameters don't provide console output, so we will continue to identify the differences through log formats. Then you have the IDS IPS with a console, which runs like so: sudo snort. This is the configuration file, a console. So that means we only want the console alert. Provides fast style alerts on the console screen. Now run the traffic generator and start ICMP HTTP. Once the traffic is generated, Snort will start generating alerts according to provided rule sets defined in the config file. And so as such, and then with parameter ACMG, header details with payload and hex and text formats, same thing, run it, and the traffic generator, and you will see the outputs as such according to the configuration file. And so let's compare the console and CMG outputs before moving on to alarm types. You can see in the given outputs above that console mode provides basic header and rule information. CMG provides full packet details. So this is the CMG version, and this is kind of the first packet detail, I guess. And then this is the console version, and it doesn't provide full packet details, right? Because there is, yeah, so there's one, at least there's 1, 2, 3, whereas this one just gave us 1. It's the ICMP and then all the other full details of it, and it gives us only 1 packet, right? I believe so. I think so. This is what it looks like anyway. Okay, so, and then running it with a fast. Fast mode provides alert messages, timestamps, and source and destination IPs. Remember, there is no console output in this mode. Start the Snort instance and do it with fast mode. And now the traffic generator. And so there won't be anything. And then there's the alarm file. So there's going to be a file generated for this. And with parameter a full. Remember, there's no output in this mode. Then run it. And what is the file going to look like? Which is, it's going to look like this, the alarm file. And then a none, disabling alerting. This mode doesn't create the alert file, however, it still logs in traffics in a binary dump format. There is no console output, and you will need to do this. So I think I'm just going to create different directories for this, because I really don't want to start searching and sifting through all the output files that are going to come from these things. So using rule file without configuration file, it's possible to run only with rules and without a config file. Running the Snort in this mode will help you test the user created rules. However, this is going to provide less performance. So instead of using the config file, which we've been doing this entire time, Snort config, instead of doing that, we're going to be using the local rules file, and then it's just going to basically do the same thing. We're going to run the same commands. IPS mode and dropping packets. IPS mode activated with Q, DAC, AF packet parameters. You can also activate this by editing Snort config file. However, you don't need to edit Snort config in the scope of this room. Review the bonus task or Snort manual for further information on DAC and advanced configuration settings. Activate the data acquisition modules and use the AF packet modules to use Snort as an IPS. And so we're going to be running it against our 2 interfaces that we have. Identifying interfaces, note that Snort IPS requires at least 2 interfaces to work. Now run the traffic generator script as sudo and start ICMP. So we ran Snort with the config file, Q, capital Q, DAQ, AF packet, and then you need to give it at least 2 interfaces, and then you did a console to put everything into the console. The alerts are going to come in the console. And packet found, priority 0, so it just shows us the packets. And yeah, that's pretty much it. So investigate the traffic with the default configuration file, and this is what it's going to look like. Execute the traffic generator, wait until the traffic stops, then stop Snort instance. Now analyze the output summary and answer the questions. Okay, and so we did alert full, and then the file is going to be in the local file, or the output itself is going to be in the local file. And so I'm going to go up back to the alerts just to remind myself what full does. Where's the alerts? Where is it? Right here. Full alert mode, providing all possible information about the alert. Okay. Alrighty then. So what are we trying to do here? We're going to run sudo snort with the config file, and we're gonna do it full and execute the generator and choose task 7 exercise. So let's go back to our previous file. Task 7. And what's in here? So use this folder as a log output folder. Fair enough. So sudo snort c etc snort dot configuration file, and we're going to do a full and L in this folder. And then execute the traffic generator. Commencing packet processing, it's running, so there you go. And there is that. And so wait for it to finish. Then stop the snort instance, which is this thing right here. And stop. Okay, we got that. And now analyze the output and answer the question. So sudo traffic generator is what we ran. What is the number of the detected HTTP GET methods? So it says it at the very top right here. So pretty easy to detect that one. GET methods are 2. So let's see. There we go. You can practice the rest of the parameters by using the traffic generator script. And that's it, huh? That's the only thing that it wanted us to answer. So I would like to actually try to run some of these things real quick. And so since we're inside the task 7, I'm just going to create my various files inside task 7. So A console is going to start, provides fast alerts on the console screen. So this I don't want to mess with because I know it's going to, well, actually, why not? Why not? Let's just do it. Who cares? So sudo snort, let's run that one more time. Sudo snort c, or I could just do this and it'll bring that. There you go. And then we're going to do a console. And run that. And it's commencing its stuff. And we're going to run this. HTTP, run that. Traffic is going to be done in a quick second. And then we will see what the output is going to look like on our screen. Look at that. We got all the output on the screen. We're going to stop the traffic. So it's still got 2 GET methods, 2 request headers extracted, gzip files, so compressed data files, decompressed data files, and total packets processed. Let's see if we can kind of scroll up and see if we can see the results from the last one as well. These are all the details from this one. That's the actual shit. Oh my god, no. This is all the stuff that's on the screen. I'm not going to scroll through all that. Okay, so fine. That worked, and we got the exercise. We at least figured that out. This one is going to provides basic header details with payload and text format. Start the Snort instance with the following command. So in the current thing, have we created any log files yet? We do. Yeah, okay. We have log files. And is that an alert folder? It's not a directory. Okay, so I guess that is use the folder as a log output folder. And we got 2 log files so far. I should have checked to see what the first one was. And so what I'm going to do is I'm going to make a directory in here for the other one just so I can kind of see the difference between these things, because I'm not going to remember these log files in the log folder. So I don't think I did CMG. I don't think I've done that. So I'm going to make a directory for CMG. Damn it, I called it CMD. So I'm going to, I think it's move CMD to CMG. And let's do ls. And so, okay, very good. We changed the name. And so we're going to go inside the CMG folder. So now that we're inside the CMG folder, there's nothing here. Excellent. So now we're going to run sudo snort c etc snort.config file, a cmg, and then l, the local folder. And then I'm going to go here and I'm going to run the traffic generator one more time. Go here and run that. At the very least, I'm kind of getting used to the process of this. And I learned the command a little bit as well. And we are learning how to give like a dump file inside the folder that we're at and all of that stuff. So that's pretty useful. That part of it is pretty useful. So now I can go back here and I can end this. And so if I do ls, oh, there's nothing created in here. So let me go back. ls, is there? No. Okay. So I guess this particular output that we did only puts it in the display. So it doesn't, Snort will, according to provider rule set and define so on and so forth. So it's going to only show here. And the results, I mean, the results are the same because we're running the same output or the same traffic file. So the results are going to be the same, but these are the details. So the details of it are different. Okay, that's fair enough. That part I understand. So now what I'm going to do then, since this thing didn't have anything, the CMG folder had nothing, we're going to go back to this and we're going to ls. And so what I'm going to do is I'm going to move CMG to fast and rename that to fast. So now we're going to go inside the fast folder because this one doesn't output anything onto the screen from what I understand. Yeah, there's no console output in this mode. So now we're going to actually run it and do it inside our current directory. A fast and do L in this current directory. And then we're going to run it one more time and that should be fine. Excellent. And now it's running it. And now we're going to run the traffic and output. I just want to make sure that I understand which ones are going to give us an output and they're not. So there you go, that's done. And that, very good. And inside the fast folder, there should now be a log folder or a log file. Excellent. So go back and now we have a fast directory that has its own log file. And that's what it's going to look like if we check the log file. And I wonder if we just read it with like nano or something, if it'll look different, right? So if I do nano snort dot whatever, open that up. Holy moly. No, this is binary. So this is the binary format of this. Oh, whoops. Cancel that out, buddy. No, I don't want to modify that. What was the read? It was sudo snort read. Got to go back and verify how to read. It was the sudo snort read. Where was it? Where is it? Where is it? Where is it? Read log name, etc. So I think I have to actually use snort to read it if I don't want it to look like a binary output, right? So sudo snort read snort.log, and then we're gonna do it in, I guess, full hexadecimal format. So it will actually read it for us and it won't be binary. Okay, cool. All right, fair enough. So I have my log file and it was generated, and it's, I truly understand that since I'm running the same traffic mode with the same shell and it's the same exact traffic, all the results are going to be different. I understand that. I'm just trying to learn how to do this in the various formats, right? So we have the fast format that we just finished, and then there's going to be the full format, which also does not have an output. So we're going to go back one directory and we're going to create a directory called full. So this is all happening. Bro, why do you do that? That's so annoying. And so right here, right, this is the command where we did the make directory says mkdir, and we ran it like that. And it's kind of, I'm gonna kind of make this a little bit wider so you could see better. because this long ass freaking directory that we're in, this whole shit right here, shows up every single time. So make directory full, and now we have the full directory right there. And so we're going to go to the full directory, and we're going to run sudo snort c, what was the name of the etc snort config. So etc snort.conf, and it's going to be a full l in the current directory. So that should run as such, and then we're going to now run our traffic generator, and we're going to run that HTTP traffic, and this thing is going to go. And then we'll have a new log file inside our current working directory. And within that directory, I know it's the same file. I understand that it's the same file, but there it is. So sudo snort read snort.log whatever, and read it in X format to show me everything. And it's gonna run, and it has 170 outputs, so on and so forth. I feel like it actually gave me more outputs this time, didn't it? Or maybe it's because I'm reading everything. All right, I'm gonna pay attention this time around, just to see if the next one is gonna give us the same number of outputs or not. And so we did the full version, and so alarm file got the full version, and if we do none, it's disabling the alerting. It doesn't create the alert file. Okay, so however, it still logs the traffic and creates a log file in a binary dump format. So it doesn't create the alert file? Oh, I see. Because if I go to the full folder, there's an actual alert file in here, right? So can Snort read this? Sudo snort read alert X. Can you read that? No, it can't read that. Can't initialize, yada yada yada. So error, fatal, quitting. So that's probably going to be inside the actual generator right here, which I'm in task 7, and I have my full alert file. And if I open the alert file, yeah, so that's what it looks like. Okay, got it. So the alert file is not a thing file. It's not a Snort readable log file. It's just it looks like a TXT file really, and it kind of gives us all of the information based on what it found, so on and so forth. But it should be similar to the actual log file, I think. Don't quote me on that, because I'm still going through a learning curve myself. So there was that, and then we did console. We did oh no, we didn't do console. Did we do console? No, the last thing that we did was full, and then from that we got the next one, which is going to be none. And then from this, I'm just not going to run none. I do want to move on to this one, which is running it without the config file, which is the rules file. Okay, that's fine. I don't want to run that either. I do want to run the IPS mode. That's what I want to run. Yes. Okay, great. So I'm just going to go to the home directory. We're going to go back home, which is here, snap. Nope. So we want to go here, which is nope. Where is it? Where are we? There we go. CD Ubuntu. There it is. Okay, great. And then go to desktop, and we are now here, task exercises. Here I'm going to create a directory, mkdir IPS, and that's going to be our IPS directory. Then we're going to go inside the IPS file, or IPS folder, excuse me. So just to give you an idea of what we just did, I took myself in the root directory, then I came home, which is right here. I came home, and inside that is our original Ubuntu, and then we went inside the desktop of that, which has the task exercises folder. So now we're in the basic machine directory that we're in right now, and within that we created a new directory called IPS, excuse me, and then IPS for intrusion protection. And so now we're inside the IPS directory, and so within this directory I'm going to run the snort command for IPS, and hopefully I can get some good results here. So sudo snort c etc snort snort.config file, and then q, capital Q, daq af packet I, and then et0 is going to be the first one, et1 is going to be the second interface, a, and I don't want it to be onto the screen, so I want it to come inside one of my log files. We're going to do full to give ourselves the full thing. So it seems to just be running. If I run this, so it's possible to run this, this one, to do this, and then modules. Okay, we did that. Do I need to run the traffic packet? Identifying, yada, yada, yada. Now run the traffic generator. Yep, I do need to run the traffic generator. So we're going to run the traffic generator, and we're going to run the HTTP, run that mofo. And let's see what happens with the IPS IDS mode. I am intrigued. I am very interested. Okay, and that finished, and now it's still running, it seems, so we're just going to cancel that out. And so, is there a log file? There's no log file. I guess because there was nothing to show as an intrusion, maybe that's why. And maybe that's why they ran it in console mode to kind of just see what's happening. Oh no, because I didn't create a log file. I was supposed to create a log file. Golly, okay, that's why. So we're gonna do this. We're gonna do this. And then at the end, I'm gonna do log like that. Okay. That's what I needed to do, right? Yes. That's what I needed to do to create a log file. So now what I'm going to do is I'm going to press enter. It should be running, and we're going to go here and we're going to do this and run the traffic generator, HTTP, do that. And it's going to run yada, 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 blah, 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 and give it to me. Excellent. Let's go here, cancel that out. Give me a log file. I have a log file and an alert file. So sudo snort read my snort log file, mofo. Do the X format. So 170 total, and everything pretty much looks the same. So no preprocessors configured, none of this BS. So I would presume that if there was something to drop and some kind of malicious traffic, it would have done so, and it would have probably made that for us as an alert or as maybe a flag or something that would show up here, right? So there was the connections on IP4, ICMP, and that's kind of basically it. That's like the only thing that it tracked, really. So there's not a lot that showed up under the IPS, but at the very least we ran one, and that's what I'm interested in, is running these exercises just so I know what the heck it feels like to type these things out. And so what we did the entire time in this entire room or entire task, the entire time we were using the configuration file as a way to, or as a rule for analyzing the traffic that came in. Because if you remember, if we did it without that, then the response was way bigger than 170. That's the big thing that I've noticed, is that when we did it without the configuration file and we were just running Snort as is, and then we were running the traffic file, there was like a few thousand results that came in. When we used the configuration file, it went based on the rules of the configuration file, and it gave us only a certain number of traffic that was exported. And these are the rules. I think this is the rule that was basically being done for us. It's looking for ICMP packets that were found, and that's basically it, right? So from any port and any IP to any port and any IP, we just want ICMP traffic, and that's what shows up right here. It only shows ICMP traffic because we were running it based on this rule, and we can always change the rule and modify to show us other things, but that's it. And so the alerts that came in would be ICMP packet found, I guess. That's technically what it would show on the screen. Let me read the log file one more time. No, it doesn't even give us this alert where it's ICMP packet found. So yeah, I guess that part of it is kind of BS. Although this is in the intrusion mode, so maybe that's what it is. Maybe that's why it's not working that. So if we went to exercise files and we went to task 7, which was the one where we created all of our stuff, and we went to full, and then if we do sudo snort read and the snort log file and give it to me in X format, it'll still be 170 because it's supposed to be 170. And does it say at least the alert file? It doesn't give the oh no, you know what? I'm such a dork, bro. Sometimes I really feel like an idiot. But whatever. No judgments here. No judgments here. The alert file should say ICMP packet found. ICMP packet found. Okay, got it. It's not gonna be in the log file. It's gonna be in the alert file that shows there was an ICMP packet found. Okay. Fair enough. I now know what the hell I am doing. Not really, but I know more than what I was doing before we started this whole thing. So we just finished task, what are we on now? We're on task 7, which was operation mode 3 for IDS, IPS, and now we're about to move on to operation mode number 4, the PCAP investigation. And so what does it do here? They're not limited to sniffing, logging, and detecting, preventing the threats. PCAP reading and investigating mode helps you work with PCAP files. Once you have a PCAP file, process it with Snort. You'll receive default traffic statistics with alerts depending on your rule set. Reading a PCAP without using additional parameters we discussed before will only overview the packets and provide statistics about the file. In most cases, this is not very handy. We're investigating the PCAP with Snort with the benefit of the rules and speed up your investigation process by using the patterns and stuff like that. So note that we are pretty close to starting to create our own rules, which should be interesting. Therefore, you need to grasp the working mechanism of Snort and learn to discuss parameters and begin combining parameters for different purposes. PCAP mode parameters are explained in the table below. So read PCAP single, it reads a single PCAP, PCAP list, and whatever you put inside that, provided in a command space separated, and then PCAP show, PCAP name and console during processing. So the R command is the read, I'm guessing, so because we did it with the snort logs. So you can still test the default reading option with PCAP by using the following command. So I'm gonna do it as we kind of go along. And where the hell is ICMP test though? That's the thing where I'm trying to find out where that file is gonna be. CD home, ls cd ubuntu ls desktop. Is that where it is? Task exercises ls config sample and exercise files. Where's the PCAP file? Maybe it'll tell us down here. It is task 8. So exercise files and task 8. Is there a PCAP file in here? There sure is. Okay, so there's PCAP files in here. So if we went at the very top and it told us to, what is it? Snort read PCAP. So if we just do snort r ICMP test PCAP, and there it is. So 68 total packets. They are IP4 and ICMP packets. And if we just kind of go through them, so let's see, it is the date and time of the thing, source IP, destination IP, time to live, ID, and very, very basic information. So they're right. So you don't get much. You can do the default reading option and it will give you probably very, very little information. So source, destination IP, and that's pretty much it. So let's investigate the PCAP with the configuration file and see what will happen. So same thing, sudo snort, configuration file, QR, and then read that thing, and then alert console and max it out at 10 from what it seems like. Please revisit the previous task if you don't remember the purpose of the parameters. The purpose of Q is one that I am interested in to see if what that is. So let's see, is it in here? Q, I think it's in sniff mode maybe. What is the purpose of Q? I can always just do a Google with it. So we can always just try to remind ourselves what -Q does. So snort Q, what does that do? Okay, so I feel like one of the easier ways to get our answer is we can just go to Bard, which is Google's AI, and search for something like, what does the option -Q do in Snort? And just do that, and that'll give us some good intel. In Snort, the Q option enables quiet mode. Okay, this means Snort will suppress most of its output, only displaying alerts triggered by rules. Okay, there you go, that's it. How quiet mode affects Snort's behavior: no banner, no packet logging, minimal alerts, and the condensed format includes rule ID, classification, source and destination IP, and ports, protocol, and the packet timestamp. So there you go. That's very, very easy to understand, and so we're just going to start doing that for our test case. So we're going to come back down here, and I'm going to kind of move this up a little bit. Then I'm going to move this up a little bit just to make it easier to view these things. And so here we go, sudo snort c etc snort conf configuration file, quiet mode, read the ICMP test, and give me an alert onto the screen, maxed out at 10. And if you don't remember, so on and so forth. Okay, did the whole thing, and here is the info. So this should only be 10, right? It looks like it's more. No, it's 10. So okay, let's see what it does one by one. So we have the first one, the ICMP ping classification, and then you have the source and destination IP. Then you have the second one, ICMP packet, priority, etc., source and destination. ICMP ping, ICMP packet. This is actually, I think, the same thing. No, it is. Yeah, this is all one. So that's all one, and then two, and so on and so forth. So we see the intelligence, and so it only, because it's in quiet mode, most of the things have been put aside with the exception of the stuff that's inside this rule. And so if you don't remember, you can see this, and so these are the things that we just found. But ours doesn't say that. Or maybe it's because I'm not looking at this in full screen mode or something. So it looks the way that it does, but ICMP packet found, mine says ICMP ping, packet found, ping, packet found, echo reply, ICMP ping, packet found, ping, packet found, echo reply, etc., etc., etc. Okay, so there is that. That's how we read a PCAP file according to the configuration file in quiet mode and putting the alerts out to the screen maxed out at 10. So our ICMP rule got a hit. As you can see, the given output Snort identified the traffic and prompted the alerts according to our rule set. And if I do that, I think there should also be in the current directory that we're in, there should now be an alert file, right? No, there is no alert file. Never mind. Okay, so now what we can do is we can, instead of reading a single file, we can read a list of files, which is similar. The command is very similar, except that all we're doing here is that instead of just doing a single PCAP file, read that, instead of doing that, we're doing a list command. So same quiet mode, everything up until this point is exactly the same. Then instead of doing that, we're just going to do this right here, where we give it 2 files to read, output onto the console, and we're not limiting it to 10, right? Well, at least not here. They do limit it to 10 over here, but they don't limit it to 10 over here. And I can create a log file too, but just for the purpose of this, I'm not going to create any kind of a log file. So we are going to do sudo snort, and we're going to use the snort config file, and q, then pcap list equals, and then we got to do it in quotes, so icmp test.pcap, and then space http2.pcap, and then close the quotes and do the alerts onto the screen right here. And so what does it say? It says there's some kind of an error. Snort, what did I do incorrectly in my command? Sudo port I did not, got it. I did not put a dot at the end of my config file. I ended up putting a /. So we're gonna edit that real quick, put a dot, run it. Now it should actually do everything, and it is doing everything, and it finished. And it's not gonna be maxed out at 10, so that's for sure, because I didn't max it out at 10, but it does show packet found, and that's basically it, right? So this is the alert that we're looking for, is that was there an ICMP packet found? And so there's a bunch of ICMP packets found, and they are either pings or echo replies or stuff like that. Mostly it's actually either ping or echo reply, but it tells us that, hey, there's a packet found. So there's a bunch of ICMP packets that were found according to the rules of the configuration file. As we saw earlier, or in the previous task, that specific rule that's inside the configuration file right now is just looking for ICMP packets. And so based on that rule, we're going to end up seeing a bunch of ICMP packets. And that's how it should be, right? So now we're going to do the PCAP show parameter, which it starts out the same. So everything is the same up until the point where we get to give them the PCAP list. And then the very, very end, it's going to say console PCAP show. And so the PCAP show is going to see, let's see, what was it again? PCAP show, tell me what it does again. Show PCAP name on the console during processing. Oh, okay, so I guess it just shows us which thing that it belongs to, right? So in this particular case, if we did, let's go down here, PCAP show. If we do this, it actually shows us which one it is. So it says in this thing, with that, we found this, and in this thing, we found this. So that's very useful. If we're gonna do a freaking list of PCAP files, I mean, that should be the thing that we did, right? That's literally how it should be at the very end. So everything is gonna look the same with the exception of doing PCAP show at the very, very end of the command. And so we're gonna press enter and see how it comes out. And so let's see if it actually shows us what belongs to what, right? It should tell me. Maybe there's gonna be a separator at some point. There is too many responses, and I am not going to keep scrolling. So is there a way, I mean, I didn't max it this, but so reading network traffic from this. So maybe I can do a search in our screen with our little search function here and see if it'll actually show that, right? So show me this. There you go. So reading network traffic from that, and then it does all these things. And then now show me the next one, which is HTTP2. Show me this. And there you go. So it shows us everything that's inside that. So I did not see a version of search in the other attack boxes that I've used before. The attack box terminal doesn't have a very visible search option like this, and it's super convenient. So obviously, when you're dealing with a barrage of data with an enormous amount of data, it's just way more convenient to be able to search the data, which is why if you're not in this kind of an environment, it's probably a good habit to output all of these results into a log file, and then the log files or the alert files can be viewed in some kind of other text viewer or text editor that does have the search function, or you can open it inside Wireshark or something like that, and through that you can search through the results. So I'm sure there's a lot of different ways. I mean, there's grep that you can do, and with grep you can try to search for things within the contents of a file, but this is just very, very convenient to just be able to click on search and then find so on and so forth. So just kind of singing the praises of whatever system, whatever Ubuntu system we're in right now. So we did PCAP show, and now we're going to run through some exercises here. So to navigate to task 8, which is exactly what we're in, and investigate the mx1 PCAP file with the default config file. What are the number of generated alerts? So let's see here. If I do, and in this particular case, we are going to be creating a log file. So that's important to understand. So these are all the files that we're in right now. And what I am going to do is I'm going to do this. I'm going to make a new directory, and I'm going to call it mx1. And I'm going to move the mx1.pcap file to the mx1 directory. So this is kind of what it looks like, just so you understand. So because I don't want to get caught up with a bunch of results that come, because we're going to get a bunch of log files, I'm sure of it. So since we've done that, so I'm going to create a new directory called mx1, which is going to belong to this particular PCAP file. And I'm just going to move, mv does move. I'm going to move this PCAP file into that directory and then press enter. And now when I do ls, you're not going to see it anymore. You're not going to see it in our general stuff, but we do see this new directory. And so if I do cd mx1, now I will actually have that PCAP file in here. And now I can run my command comfortably and only deal with the directory that I am in. So what I'm going to do is sudo snort c etc snort.conf. That's, I keep doing / .configure conf file. There you go. And then we're going to do a full to give me full alerts, and it's going to be inside my current folder, and I'm going to read the mx1 PCAP file. And do I need to do generate? No, I'm not, because I'm reading a PCAP file. So there you go. There you go. All of that stuff. Great. So what is the number of generated alerts? Does it show me here? Yep. So we have action stats 170 alerts. So that is on our terminal. Great. Keep reading the output. How many TCP segments are queued? So let's try to scroll up and see our TCP segments here. Is there a difference between TCP segments and just TCP files? Boom. Okay, so I think this is what this actually means. So we do see, I mean, it's the same line item as before, where it says TCP, but I just wonder if that's what queued means. No, that's not it. So it's not 41 TCP segments that have been queued. So it should be a different type of section. So let's see what I can find here. Okay, there we go. So there is actually an item called TCP segments queued, and that answer is 18. So there's that. So keep reading the output. How many HTTP response headers? So what we're looking for is a specific line item, and this is right here. So HTTP response headers extracted should be 3. Great. And so now we're gonna do the same file. So we're gonna read the same file, but we're gonna do it with the second configuration file that's inside Snort right here. So we're doing literally the same thing, except we're just gonna run the second config file. So just for my own reference, I'm going to run an ls command just to see where my, so that's my snort log that ends in 501, and it was created January 21 at 128. And that is now going to be my reference point for this. And so from here, we also have an alert that was generated as 128. So there's that. I mean, I could do scan one and move them into that, but I'm just gonna kind of, because I think we're only dealing with the, yeah, we're only dealing with the mx1 file for one more command. So snort c config is going to be the config2 snort v2 conf file, and then a full l in the current directory, give me r, give me an r. And so there's the new command right here. So sudo snort -c for the config file. This is going to be the second config file, and you want to give me full alerts inside the current local directory. I want you to create that log inside this directory and read this mf or mx file, excuse me. So there is that. And so now let's see what was generated. So now we have 2, right? And there's the alert. Oh, the new alert replaced the old alert. Interesting. So there's only one alert file that'll be generated. And then we have the 2 log files, one at 128, one at 132. And so what do we got here? We got, what is the number of generated alerts? So let's go back to the top real quick and look at our generated alerts. Okay, so the output for this particular config file is actually much bigger. There was a lot of lines of output. So in this case, I'm going to do this, and I'm going to do alerts, search that, and oh no, there's a lot of alert files. So alerts in this case, I think is going to be 68. So let's see, 68. Does that work? That does work. Great. So okay, that's good. What is the, so investigated with the default configuration file. Oh no, that's it actually. So we're moving on to the mx2 PCAP file. Got it. So okay, so we're done with this one, but it was a much bigger output that came with that. So now we are going to deal with the mx2. So I'm going to create a directory called mx2, and I'm going to move the mx2 PCAP file .pcap into the mx2 directory and do ls, and so now it's gone. So now we're going to go into the mx2 directory, and now we're going to run our command with the default configuration file. So as you should be familiar with it by now, it's a fairly simple command, and we're going to do a full alert inside our current directory, and we're going to read mx2 pcap mx2 dot pcap. There you go. And there it is, and it is now running. And so the question is going to be, what's the number of generated alerts? And so what if we just did search, find, do alerts, and if I did this alerts is 170. So let's see if this is the same. No, it is not the same. I think I'm looking at a different file. 340 maybe. I think that's the number. There you go. That's the number. So 340. What is the number of detected TCP packets? So in this particular situation, it's going to end up in that one list. So it's a different, it's not asking for TCP segments. It's looking for TCP packets, which is this right here. And so this should actually be 82, right? Very good. And so investigate the PCAP and PCAP files with the default configuration file. What is the number of generated alerts? So now we're going to do a list version of this, and we're going to move all of those into a new, oh no, but it's asking for mx2. Son of a gun, are you kidding me? So I need to move it back. So how do I move it back? Let me see. I think you move it back, ls. I'm gonna do copy mx2 just so I don't ruin it, to mx2 to 3.pcap. So that's gonna be the new file. So now we should have 2 of those. Okay, great. And so it was, I think it's move mx to 3.pcap, which is going to be the new file. We're going to move it to one directory back like that. Okay, and if I go back, is it here? Nice. Okay, cool, I remember. Good stuff, good stuff. Okay, so just to give you an idea of what we just did. So I didn't want to mess this up, so I created a copy of it using the cp command, and you give the copy, the file that you want to copy with the copy name that you want to have. So I just added a 3 at the end of it. And so this is the copied file of the exact mx2 file. And then I moved the new file to this. And so this is what that means. When you do .. you're going back one directory, right? So I moved it back one directory. That's basically all I did. And then I went back to that one directory. So now we're, instead of being in the mx2 directory, we just came back to the task8 directory. And now we have our copied file in here. I love it when basic things work. It's very exciting to me. Okay, so now we're gonna do a list read kind of a thing. So sudo snort c etc snort dot config. So we're using the regular configuration file, and we're gonna do a full read, and we want the log to be in the current folder, and now it's gonna be pcap list equals mx2.p, oh, not 2, because it's been copied, so 23.pcap, and the mx3.pcap. And then what I want to do is I want to do pcap view, right? That's what it was. I think that's the command to actually view it on the screen, or pcap show, excuse me. Pcap show. There we go. That's what I messed up. I didn't have the initial quote. That's what I missed. Everything can fall apart with the missing of one character, you guys. So now that should be fine. There you go. And voila. Great. Okay, so what is the number of generated alerts? And so we're gonna do a search for find, and we're gonna do alerts. And I'm gonna do, I think it's this. That brings me up, and then if I do this, and then do one more, 1020, there you go. Combined 1020. Heck yeah, buddy. Let's freaking go, bro. I am excited. I'm learning more about Snort. And this is just the intro, the intro room, by the way, because the other room, as I'm going to remind you, there's challenges and live attacks and all this kind of shit. So I'm already kind of dreading those rooms, because I know I'm going to be recording them, and it's probably going to end up being a long recording session for me, but the edited version is going to be short, because I'm going to remove all of my trial and error for the most part, and all of the lulls and all these things. But yeah, I'm not excited about no, I'm excited. I'll be fine. I'm gonna psych myself out. I don't want to psych myself out. And the freaking thing keeps disappearing. It's so annoying. What the hell? Anyways. Okay, so here we go. The last piece, or not even last, where are we? We have a couple more. After this, we have operation logic and the conclusion. So we're almost there. Okay, so Snort rule structure. Let's look at the rules a little bit, just so we can see what's happening here. It's essential to learn these things. The primary structure looks like this. So you have the action, so alert, drop, or reject. The protocol, source IP, any, direction, both directions, any. And then the message, reference, SID, and rev, or revision. There you go, that's what that stands for. So the alert itself is the first word that comes in. So the action type is alert. and the protocol type is ICMP. So in this particular rule that we're analyzing, the action type is alert, the protocol type is ICMP. There's any source IP to any source port going in either direction to any destination IP and any destination port. And then the message is, we found the packet, and the reference ID, the reference number, I guess, or the reference, excuse me, is the CVE vulnerability ID. This is, from what I understand, it's actually from the CVE database. And then you have the rule ID, the SID, as the rule ID that we're going to give it. And this repeats with every single one. And it shows as the same rule ID with every single instance that shows up. And then you have the revision information, the rev1, and then it looks like there is a semicolon and a closing parentheses. So the first part of this is not enclosed in parentheses. Then you have an opening parentheses, and it shows you all of this information. Then you have the closing parentheses, but there's a semicolon at the end of this to show that this piece is its own segment. So there's one segment here, one segment here, one segment here, and one segment. So 4 segments inside these parentheses. Each rule should have a type of action, protocol, source, and destination. Source and destination ports are an option. Remember, Snort is in passive mode by default, so most of the time you will use it as an IDS. You will need to start inline mode to turn on IPS, but before you start playing with inline mode, you should be familiar with rules. So the Snort rule structure is easy to understand but difficult to produce. You should be familiar with rule options and related details to create efficient rules. It is recommended to practice Snort rules and option details for different use cases. We'll cover basic rule structure in this room and help you take a step into Snort rules. You can always advance your rule creation skills with different rule options by practicing, that is not how you spell practice, different use cases and studying rule options detailed in depth. We will focus on 2 actions, which is alert for IDS mode and reject for IPS mode. Rules cannot be processed without a header. Rule options are optional parts. However, it is almost impossible to detect sophisticated attacks without using the rule options. So the action is alert. It generates an alert and logs it. Logs the packet. Drop blocks and logs the packet. Reject blocks the packet, logs it, and terminates the packet session. So this is the IPS mode, because if something shady is happening, it terminates that session. Where this one blocks the IP address, this one blocks it, logs it, and terminates the session. The protocol identifies the type of protocol that's filtered. So Snort 2 reports only 4 protocol filters in the rules, which is ICP or IP, TCP, UDP, and ICMP. And what does the note here say? Oh, we know this already. However, you can detect the application flows using port numbers and options. For instance, if you want to detect the FTP traffic, you cannot use the FTP keyword in the protocol field, but filter the FTP traffic by investigating TCP traffic on port 21, which is the port for FTP. So that's important to understand. IP and port numbers. So IP filtering, alert, ICMP, that would probably be the source port, right? Source IP on any port to any destination IP destination port. The message is ICMP packet from such and such. This rule will create an alert for each packet originating from this IP address. Filter an IP range, so alert ICMP this range, so it chooses a subnet, and so anything that's inside of this subnet, so it could be 56, it could be 12, it could be 110, whatever, on any port, and then same thing, so ICMP packet found. Now this will create a pack originating from this subnet, right? Easy to understand. Filter multiple ranges, and so you just put that inside square brackets and separate them by commas. So same first subnet and new subnet on any port, any destination, any port, and it will create an alert for a packet originating from this or this subnet. and exclude IP addresses and ranges. So the negation operator is used for excluding specific addresses and ports. Negation operator is indicated with the exclamation mark, and so that's not in the text of coding or in the context of coding. It's considered to be not. So alert anything that is not from this subnet, and so this is going to create an alert for each packet not originating from this subnet, right? Port filtering, so alert TCP, so it's no longer ICMP, now it's TCP. So alert TCP, any IP, any port, any IP, any destination IP that has to do with port 21, and port 21 command activity detected, meaning this is going to create an alert for each TCP packet sent to our port 21. Ideally, I think that's what this means. On the destination side, it's all of our IP addresses and all of our ports. And exclude a specific port, so anything that is not port 21. So, create an alert for any kind of traffic that's not port 21. Filter a port range, so alert TCP, any source IP or port, and any IP that is inside of these range of ports. And this is also similar to what goes on in Python coding or other coding languages, where if you put a colon between the two numbers, it goes from 1 to 2024, including 1 and 2024. So it's creating an alert for TCP packets sent to ports between these things. And a port range type 2. So I guess this kind of goes from, what is it? So less than or equal to 10,024. Oh, I see. So maybe this one in particular doesn't include 1 and 1024, but this one does include 1024, right? Less than or equal to 1024. So let's see here. Why is this zooming in too much now? What the heck? Okay, there you go. Where were we? Okay, port type 3. So TCP any 1025 or greater. So higher than or equal to 1025 port. And port range type 4, any, and so only these two ports. So if you put them inside these square brackets and you separate them by commas, it only filters those two ports. So the rules are if you just understand the basics of scanning and TCP and all of that stuff, the rules are pretty standard. It makes sense. But then again, these are basic rules. So the direction is important here. So back and forth. So when you have both of these two symbols, it's bidirectional. When you have dash this, it's going from the source to the destination. There is no destination to source. So it's either bidirectional or from the source to the destination. So this thing right here is bidirectional, as you can see, right? That's the source, that's the destination, and then these are the rule options, etc. There are three main rule options to Snort. You have general rule, payload rule, and non-payload rule. General rule is fundamental options, and payload rule is to investigate the payload data. These options are helpful to detect specific payload patterns. And then non-payload are options that focus on non-payload data, so help create a specific pattern and identify network issues. Then you have general rule options, which is create a message. So give me a basic prompt next to the alert that says such and such is happening whenever the trigger goes off. And usually the message is a one-liner that summarizes the event. And SID is the Snort rule ID, comes with a predefined scope. Each rule must have an SID in a proper format. There are three different types of scopes. Less than 100 is reserved rules. 100 to 999,999 are rules that came with the build, and then anything above 1,000,000 is rules that are created by us, the users. The rules we will create should have an SID greater than 100 million. Another important point is that SIDs should not overlap. and each ID must be unique. Okay, similar to like the rules for the ports. It's like each port can only be used by one service on a given IP address. The reference. Each rule can have an additional information or reference to explain the purpose of the rule. That could be common vulnerabilities and exposures ID or external information. Having references for the rules will always help analysts during alert and incident investigation. And Snort rules revision. I think that's what that was again. Can be modified and updated for performance and efficiency rules. Rev option helps analysts to have the revision information of each rule. Therefore, it will be easy to understand the rule improvements. Each rule has its unique rev number, and there is no auto backup feature on the rule history. Analysts should keep the rule history themselves. Rev option is only an indicator for how many times the rule has had revisions. So if we go up here, this is its first revision. I'm assuming that means that this is the first instance of the code. And now we have payload detection rules. So the content, which is the payload data, it matches specific payload data by AC, hex, or both. It is possible to use this option multiple times in a single rule. However, the more you create specific pattern match features, the more it takes time to investigate a packet. Following rules will create an alert for each HTTP packet containing the word get. This rule option is case sensitive. So AC mode alert TCP any source IP and port to any destination IP on port 80, and a get request was found. Content is get, and SID is that revision 1. Hex mode would be same thing to start, get request found, content. Instead of saying get, you have to have the hex reference for each one of those characters, and then the SID and everything else is the same. Disabling case sensitivity used for enhancing the content searches. So this is the alert. So TCP any 80 get request found, content get, no case. So this is for disabling case sensitivity, which I think is useful in most cases. And you just put that right after the content get, no case, and then everything else stays the same. And then prioritize content search to speed up the payload search operation. By default, Snort uses the biggest content and evaluates it against the rules. Fast pattern option helps you select the initial packet match with the specific value for further investigation. This option always works case insensitive and can be used once per rule. Note that this option is required when using multiple content options. So the following rule has 2 content options, and the fast pattern option tells Snort to use the first content option, in this case the get, and for the initial packet match. So alert TCP any, and then it goes to port 80. The message is get request found, the content is get. We're using a fast pattern option, and then the content is www and that. So the 2 rules, or the 2 options that we've chosen here, are fast pattern and content www. So no non-payload detection that focus on non-payload data. So filtering the IP ID field, alert TCP any, message ID test, ID 123456, SID, so on and so forth. So, okay, I guess it seems like, yeah, it's just doing the IP ID. Filtering the TCP flags. So we did this in one of our previous videos. I think it was the Nmap video, the series of Nmap videos that we did, where we had to learn about these different various flags that come within a TCP packet. And so it says alert TCP any flag test, and then the flags S, so for a SYN packet, SID and everything else is the same. Filtering the packet payload size, so D size, minimum and maximum, D size greater than 100, D size less than 100. So any, and D size, I'm probably sure it's data size. And then message is sequence test, or SEQ test probably, desize 100, between 100 to 300, and then everything else is the same. And then filtering the source and destination IP addresses found for duplication. So any, and the message is same IP test, and then you do same IP semicolon, everything else is the same. So remember, once you create a rule, it is a local rule and should be in your local.rules file. This file is located under the Snort rules, local rules. A quick reminder on how to edit your local rules is shown below. So sudo gedit and then the rules file, and this opens up the rules file. And so these are the rules. So local rules, they're commented out by a hashtag, very similar to Python. And so none of these first, from line 2 to line 6, none of that applies. And then this is the first rule. And so it says, alert ICMP, yada, 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 ICMP packet found. And this is the rule that we were messing with in the previous exercises. So there are some default rules activated with Snort. These rules are deactivated to manage your rules and improve your exercise experience. For further information, please refer to task 10 or the Snort manual. By this point, we covered the primary structure, understanding and practicing fundamentals suggested before creating advanced rules and using additional options. And we've done a lot of stuff. So now use the attached VM to navigate to the task 9 folder to answer the questions. Note that you can use the following command to create the logs in the current directory, which is task 9. So task 9 PCAP, write a rule to filter the IP ID and run it against any the given PCAP file. What is the request name of the detected packet? So first we want to go to our local rules file. And do I need to run the... No, because now I'm doing everything with PCAP files, so I think, right, this is all PCAP files? PCAP. Okay. All right, so since we're doing PCAP files, I'm just going to leave this particular directory. I'm going to go back to our root directory. Whoops, wrong. Okay. And so the command to get us into the rules is sudo gedit etc snort rules local.rules. And there's that. So this is our first rule. So now we're gonna do this, and we're gonna do, it says write a rule to filter IP ID 369 and run it against the given PCAP file. So the one that did the test IP ID, filtering the IP ID field, it's that right here. So I'm gonna comment out this one just so I don't activate both of them, and I'm gonna do this, and now it's gonna be alert TCP any and any, and the message is going to be ID test and semicolon ID is going to be, what is it? 35369, and that's the ID that we want to filter. And then we're going to move on to SID 1000002, right? I think I can put a space, revision 1. So that should be fine. So now I'm going to save this. Right? That's fine. It's saved. So if I close this, and I'm going to run that one more time just to make sure that the edit actually went through. And there you go. The edit did go through, but it's been commented out. I don't want it to be commented out. I want it to be live. So run it again, and now, has it been commented out? It's not commented. Okay, great. So let's remove that initial space too, just to see if it actually works. So we got the local rule, and now I can run it against my file, right? So I can go to cd back 1, and we're gonna go to task 9, and inside task 9 we should have a task 9 PCAP, which we do, and there's a local. Man, I'm supposed to edit the local rules file? Bruh, are you telling me that I just changed the overall rules? That's so freaking annoying. Ugh, I shouldn't have edited that main file, it seems. Whatever, bro. I'm so annoyed right now. So what is it? 35369. 35369. That's what I'm filtering. That's so annoying. I didn't know that there was going to be a local rules file in there. 35369. Alert TCP any, and then any, and it's going to be message is ID test, and ID is going to be 35369, and SID is going to be 1000002, and then rev is 1, and that's it. Okay, so save, close this bitch, and let's go here, do it one more time. Okay, great, that actually is running. I should have checked the file or the directory originally. Okay, so great, now we have that. So sudo c local rules. Give me a alert of full, give it to me in the current directory, and I want you to read task 9 PCAP. What did I do wrong here? Oh, there's no freaking Snort. Huh, I didn't even use Snort. Okay, sudo Snort, C local rule, rules, right? Local rules, is that what the name of the thing is? Yeah, it is local rules, great. A full L dot R, and then task 9 PCAP. Read it. Okay, did. And so what does it say? It says, what is the request name of the detected packet? Okay, so the hint says, try to filter different protocols like TCP, UDP, and ICMP under the ID 35369. And I think the one that I only have is TCP. So if I modify the rule to include all of the other ones as well, should be fine, right? So let's go here. We have that, and we're gonna modify the local rules, and we're just gonna copy this to be all of them. So we're gonna do copy, and I'm gonna do enter. There's gonna be one here. Oh, so copy, paste, and paste. And so this is going to be UDP, and it's going to be on SID 103, and this will be ICMP, and this is going to be 104. And all of this rest of it is going to be the same. So we're going to save the file, close the file, and we're going to run our command one more time. Sudo snort, local rules, yada yada yada, enter. Okay, so I believe this is it. So this is the only alert that showed up in our alert file, and shows up as ID test, and it shows up under the fourth one, which is the ICMP rule, and timestamp request seems to be the message. So I think that's it. So we're going to copy this and go here and paste it. Hey, that worked. Look at that. Oh, that is beautiful. Okay, so create a rule to filter packets with the SYN flag and run it against the given PCAP file. What is the number of detected packets? All right, so we're going to go back to our rule edit command, which is sudo g edit and local rules. Okay, so now I can comment these things out. And I need to do something that filters for the SYN packet, right? So actually, you know what I'm going to do? I'm going to do the same thing, except I'm going to do it against. So can I do undo, 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 undo? Very good. So do that. We're going to copy all of these. Then we're going to come down here and we're going to paste them. And the first three, I'm just going to, whoops, do that, and do that. So we commented out the first three. So now we have a TCP, UDP, and ICMP rule attached to searching for SYN flags. And so it's going to be flag test in this one. And we're going to copy that, come here, paste, come here, paste. Ah, crap. Okay, and so the thing is now going to be flag. So I'm filtering for a flag, which is flag S. So it's going to just change this little section right here, and it's going to be flag colon capital S. 4, 5 right there. And we're going to copy that, and we're going to come here, and we're going to paste it over this little thing. We're going to come over here, paste it over this little thing, and I don't think this matters, but just in case, I don't want it to get messed up. So that's 5, and then come down and go here, and 6, and come down, go there, and that would be 7. Okay, so the rule is applying to any TCP, UDP, or ICMP, and any, and it's going to be a flag test for the SYN flag, and that should be it. So now I'm going to go back down, and now I'm just going to run my command one more time, which is going to be sudo snort c against local rules, and give me a full response alert type of a thing, and you're going to read task 9.pcap. Okay, local rule flags. Okay, flags. Save. You bastard. One freaking character can just throw everything off. That's one of the good things and one of the annoying things about everything. And so there we go. Now let's run it one more time. TCP options, fatal error quitting. So what is the TCP options on non-TCP rule? So TCP options on a non-TCP rule. Oh, ICMP, I understand. So we're doing a TCP flag. So none of the other rules actually even matter. So it only applies to TCP. That's the thing. So I'm just going to cut these out, and we're going to save this. What are you doing? We're going to save this, and we're going to run it one more time. And this is third time is a charm right here. There you go. It ran, and it finished, and it gave me, I'm sure, a new alert file right here. So I'm going to refresh this page. And this is going to be our, new alert. And there we go, we got it. Oh, and so that's what happens. So when an alert comes up, it just appends it to the current list of the alerts. Great. So now it says, what is the number of detected packets? I only see one, buddy. Is there any more? I think it's one. There you go. Nice. All right, so clear the previous log and alarm files and deactivate, comment out the old rule. Okay. Write a rule to filter packets with push acknowledge flags and run it against the given PCAP file. What is the number of detected packets? Okay, so we want to, it says clear it, so I guess I'm just gonna do this. Delete this file, right? Is there delete? Yeah, move to trash. There you go. And it says, I don't know if I need to clear the previous log files. So now I'm going to recreate a new rule set. Rule filter packets with a push acknowledge flag. And so I want to say that I could do S and P. Let's see if that'll work. So if I just do S and P, or no, P, it's P and acknowledge, so PA. We'll see if that works. I'll separate them by commas just to see if that'll work. Save that, and let's run it again. Okay, I mean, it looked like it worked, so let's see. Open it up. Oh my God. Okay, so acknowledge, acknowledge, acknowledge. And then, is there any push in here? All of them seem to be acknowledge flags. So can I do control find in this? I can do control find. So if I do PSH, what about ACK? So there is ACK. So I can do ACK, but there was nothing that showed up in PSH. What is the number of detected packets? We're going to say 216, because that's the number of acknowledged flags that showed up. Clear the previous log, and create a rule to filter packets with the same source and destination IP, and run it against the given PCAP. What is the number of packets that show the same source and destination address? What was that like? How do we do that? I see, so there it is. So this is the actual flag. So same IP is the option. So yeah, non-payload. Okay, cool. So the rule, so we're gonna close this out. We're gonna delete this alert file, and just for the hell of it, we're also gonna delete these log files. And so now we're gonna go back and edit our rule file and comment out these things. At this point, I feel like it's just a good idea to have all these for the hell of it. Why not? And so I'm gonna copy it. Why not? We'll just copy this, then paste it one more time. Okay, so what we want to do is we want to do a UDP and we want to do a TCP. We're going to create a new flag called same IP, or a new message, and we're going to do another one, same IP. And instead of having flags over here, we're just literally going to put the command same IP, and change the ID of this to 6, and we will do, oh look, it changed it for me? That's weird. 7. Oh no, I typed. Wow, you guys, I'm kind of like running on fumes right now. Same IP. Okay, cool. So we have two rules: UDP, TCP, filtering any source destination, alert IP, and alert IP. So maybe it's an IP rule. Whatever, we'll run a couple of different instances of this thing just to see what ends up working and being official. So it could be alert TCP, UDP, or IP, and then any same IP test, and should be good. And so this is going to be 1000 or 100 or 1 million. There you go, 1,000,008. Okay, so that should be a pretty good set of rules right there. So now it just says what? It says to da-da-da and run it against the PCAP file. What is the given number of packets? So, okay, maybe it's the IP rule that I should have done. So I'm gonna do specifically search for this one because it showed up on multiple instances. So 13 is what that shows up as. And so what if we do 1,000 or 1,000,007? There's 7 of them, and what if we do 6? There's 3 of them. So these were the UDP ones, right? No, these were the TCP ones, and then there's the UDP ones. It has not specified. It just says, so it could be any of them, really. It could be 3, so it's not 3, 7. 7 is the one. So yeah, there was the 1,008 rule was searching for the same IP, so that kind of feels like a weird type of thing, and I should have messaged them differently just so I can understand. But this is very useful, the different SID numbers. That was the reason why we were able to find it. And I'll close this just so we can review the rules, just so you can kind of see what the search parameters resulted in. So if I run it one more time, and so this is same IP, and I'll change the messaging so that we can kind of also see the same TCP IP, and then this one is same UDP IP. And 1,007, I think, was the one that actually got us the appropriate number of results. And so we're gonna save it, we're gonna close it, we're going to empty this out because this is going to bring a bunch of results. And so we're going to run that one more time, and so it'll finish, it'll give us a new alert file, and then we open the alert file, and inside it we should see a bunch of different things, right? So same IP, same IP, same UDP IP, same UDP IP, so on and so forth. So the response, I think, was supposed to be for the UDP IP, although it is not specified here. It doesn't tell us what we're going to be trying to search for. There you go, same UDP IP. There's 7 total results that came from that particular rule, and so that was the answer. And there you go, got that. That was not bad. I'm excited. I'm learning, you guys. We're learning here. We're learning. I hope you're learning too, honestly. And yeah, so there's that. And so now, case example, an analyst modified an existing rule successfully. Which rule option must the analyst change after the implementation? An example is the analyst modified an existing rule successfully. Which rule option? Oh, the rev. So the revision is what they got to change. Heck yeah, buddy. What do you know about it? Okay, cool. So that was the end of the task 4. This was a long task too, for Snort rule structure. So now we're going to move on to task 10 for the Snort 2 operation. So we did Snort rule, and this is Snort 2. So I guess it's like the second version of Snort. And so operation logic points to remember. So what do we got here? We got the main components of Snort are the packet decoder, preprocessor, detection engine, the logging and alerting outputs and plugins. Packet controller collects and prepares the packets for preprocessing. Preprocessor arranges and modifies the packets for detection engine. The primary component that process, dissect and analyze the packets by applying the rules. Log and alert generation component. Then you have the output integration model that alerts to syslog or MySQL, and additional plugin, rule management, and all of that stuff. So there are 3 types of rules available for Snort, which is community, registered, and subscriber rules. So the free rule set under GPL v2 is publicly accessible, no need for registration. Free rule set but requires registration, and it contains subscriber rules with 30 days delayed. I see. Okay. So these guys get the rules first, like immediately, and then it's updated twice a week, it says. And these guys get the rules that these guys get, but within 30 days, or 30 days after, excuse me. And so we can download and read more on the rules here, which is what link? What do we got? So the downloads, I see, so Snort 2, Snort 3. So there's new rules, obviously, that have come out ever since that specific room has come out, because Snort 2 is what this is about, and we just saw that there's a Snort 3. So there is constant updates that are happening to this, which is exciting. Once you install Snort 2, it automatically creates required directories and files. However, if you want to use the community or paid rules, you need to indicate each rule in the Snort configuration file. Okay. Since it is a long, all-in-one configuration file, editing it without causing misconfiguration is troublesome for some. That is why Snort has several rule updating modules and integration tools. To sum up, never replace your configured Snort config files. You must edit your configuration files manually or update your rules with additional tools and modules to not face any fail or crash or lack of a feature. So there's the Snort config file, and then their local rules files, which are user-generated rules. And then, as you remember, there was a config version 2 that we messed with in this room. So that's kind of the best practice, I guess, is like download the new rule file or the configuration file and just update the name of it, so you're not appending to the current rules list, because it probably is already a very long list, and if you keep adding to it, it's just going to get longer and longer, and the loading time might be different, it might crash, so on and so forth. So it's probably better to have several files. So we're going to overview the main configuration, which is snort.conf, so sudo gedit, and then we're going to go to that configuration. To the step 1 portion, set the network variables section, and these are the network variables. So you have this is where we are protecting, which is going to be the home net variable. The external net is the external network, so we need to keep it as any or not home net. The rule path is the hard-coded rule path. The SO rule path are registered and subscriber rules, and the pre-proc rule path come with the registered and subscriber rules again. So then you have step 2, configure the coder section, and so you have the config DAQ, the IPS mode selection, and the example is AF packet. We messed with that a little bit earlier. Then the config DAQ underscore mode activates the inline mode, and then the log dir is the log path, which is the hard-coded log file, the log directory. The data acquisition models. The data acquisition models are specific libraries used for packet I/O, bringing flexibility to process packets to select the DAQ type and mode for different purposes. There are 6 modules available for the DAQ. So you have PCAP, which we played with a lot, AF packet, IPQ. So this is for the Sniffer mode, inline mode for IPS. IPQ is inline mode on Linux. Using netfilter, it replaces the Snort inline patch. NFQ is the inline mode on Linux. IPFW is inline on OpenBSD and FreeBSD with the PF and IPFW walls, and testing mode of inline normalization. So the most popular modes are the PCAP and the inline IPS packets. And so then we get to step 6, which is configure output. It manages the outputs of the IDS IPS actions such as logging and alerting formats. The default action prompts everything in the console application, so configuring this part will help you use the Snort more efficiently. Sorry about the honking in the background, my neighbors are assholes. Then you have the tag name, so it's number 7, customize the rule set. So site-specific rules, hard-coded local and user-generated rules, includes the rule path, which is local rules, and then include rule path hard-coded default downloaded rules path, including the rule name, so on and so forth. So that's it. This is commenting, and it happens in a lot of coding languages. So if you want to use something, you would remove this so that it's no longer a comment. And there we go. We read through the basics of this thing, and I'm just going to open up the specific file for us just to kind of get a little view of it. So etc snort.config file. And it's going to open this file for us. And as you can see, there's a lot of commented out lines over here. And this is one line, by the way. So as you might be able to see that there's no comments at the beginning of these two. But then when you look at the numbers, so this is line 16 and there's a comment, and then that's line 17. So this is actually one long line. So these are the rules right here. So step 1, the network variables, and then you get to kind of see what's available. So the IP variable is homenet any. So this one has not been commented out. All these other ones have been commented, with the exception, no, actually, I'm sorry. So that's active. External net is also active. DNS servers, SMTP servers, HTTP, all these things are actually active. And then so if we go down a little bit more, configuring the configuring the decoder, and so disable decode alerts, disable there's a bunch of rules. And I mean, at this point, I'm just reading. Like most of these things, I have no idea what they are, and I would be guessing to try to figure out what they actually are. It's just instead of assuming. So here's the thing, right? So this thing kind of gave us a little bit of an overview, and it gave us a general explanation of what some of these variables are and what some of these tag names are and what they do. But clearly, there is way more to these options than just that. And so they jumped from step 2 to step 6, by the way. So they didn't cover step 3, step 4. Where the hell is step 4? Let's see what's over there. Step 4 is the dynamic load libraries. They didn't cover step 5, the preprocessors. So they didn't talk about any of that stuff. And they just jumped immediately to step 6, which step 5, look at how long step 5 is, right? It's kind of insane. And then now we just got to step 6, which is like a really short ass little section. So it's like nothing, right? So it's just it's good to know what these log files are. And I'm sure as we kind of advance through the rest of the rooms for Snort, we're going to figure out what a lot of those things are too, so that we just get better at not only editing these things, but understanding how they actually work and creating the rules and all of that stuff. So this was task 10 for Snort 2, and as you saw, there's also a Snort 3. So they're going to constantly update these rules and make them more accessible to us. And so we are now at the conclusion. So in this room, we covered Snort, what it is, what it does, and how to create and use the rules to investigate it. There's certain task files that I guess we could use for future reference. So understanding the fundamentals is crucial before creating rules. Do not create complex rules at once. Try to add options step by step or create multiple rules. Do not reinvent the wheel or modify or enhance it if there's a smooth rule. Take a backup of the config files before making any change. This is so important. It seems so simple, dude. This seems like such a simple line item, but you have no idea how many times I've messed things up by not using a backup or by not making copies of certain files and just editing the normal. I have messed so many things up, okay? So just learn from my experience and make backup files, okay? Never delete a rule that works properly. Comment it if you don't need it. That's another thing. It's like, dude, just, it's so common sense. You would think that people do these things, but not me. So newly created rules should be tested. So you do -T before migrating them to production, so you can actually test them, so you know what the hell's going on. And then we got the challenge room, which is going to be the next one, which is live attacks, or not live attacks actually. We just did Snort, then there's the basics, and then there's the challenge of live attacks. So I'm gonna also go through the basics room before I do the live attacks, because that is not what I'm trying to do. There's a cheat sheet here, which is awesome. So a great way to quickly recall Snort rules and commands is to download and refer to the TryHackMe cheat sheet. Look at this. I wonder if this is what the task file is. I think it is what the task file is. So what if I download it? What shows up? Oh, I can't download it. What is it? Download task files. That is the cheat sheet. Hell yeah. Okay. I'm gonna keep that. That's very, very useful. The Snort cheat sheet. And so, I mean, let's kind of look at it real quick. But I mean, it's basically a cheat sheet of everything that we've covered, right? So, the global commands here, do not display, the specific interface. Then you got your sniffer modes, the logger modes. This is super freaking useful. I mean, thank whoever made this. Who's the oh, TryHackMe made this. So thank TryHackMe. I mean, these are the kinds of things that it's just super freaking useful to know, right? And because it's free, this is the free room. Remember, this is a free room. I highly recommend you go and try this out, because this may be the longest video that I have made so far. And I recorded it in 2 sessions, and this is the second session. It's going at an hour and a half right now. And of course, I'm going to edit it, and I'm going to remove the lulls and the blank spaces and a lot of other stuff. So I'm going to hopefully condense this whole thing to be less than 2 hours. But all in all, I think I spent at least 3 hours in this room recording this video and doing all these things and trying to figure all this stuff out. So this is a really useful room. So far, I think this has been one of the ones that I've gotten the most impact out of, especially since it was a live recording of me learning as I was recording. The ones that I've done before, clearly, I kind of breezed through them. I speed through them, but I wasn't. I was learning this as I was going, and I was getting nervous. I'm like, man, what if this ends up being, what if I embarrass myself? Whatever. It's all good. Who cares? But yeah, we learned a lot. I learned a lot for sure. So I hope you learned too. And this was a free room. So go ahead and get yourself your subscription to TryHackMe. And if you want to use the subscriber version where you actually get access to everything else, then make sure you click the link in the description below so that you get access to all that stuff too at a discount. And so let's see, the basics room is not for free, right? So that was the intro to Snort that we did. And of course, the basics room is not for free, and you need a subscriber for that. And I'm guessing the live attack for that is also requires a subscription. Oh no, the live attack challenge is a free room. So there you go. This you can actually do for free as well. But the Snort challenge basics is not a free room. So you would need some kind of a paid VIP type of a subscription to TryHackMe. And again, you could just use the link in the description below to get a discount for that and get to hacking. You know what I'm saying? This is your boy Hank Hackerson at Hank Hacks Hackers. I hope you learned a lot from this video, because I sure as hell did. And yeah, so make sure you like, subscribe, share, comment, turn on the notification bell, all that good stuff, so that you get notified the next time a video comes out. Because best believe there's going to be more videos coming out. And I'm just excited to keep sharing these things with you guys. So peace, love, and chicken grease. If no one else loves you, Hank loves you. And I'm going to see you in the next room. Peace.